R has a number of built-in functions to generate random variates. In this video, I'll demonstrate typical ways to generate a single random number, a random sample, and random variates from normal and binomial distributions. So the most basic way to generate a single random number is the AreUnit function. So AreUnit, which kind of looks like runif, but you should think of it as R for random and unif for uniform. So I want to pick a number from 0 to 1 in a uniform way. And this will give me a fractional number or a decimal number between 0 and 1. And each time I run it, it'll give me a different random number. Now I can adjust that range. I can run if I want one value or one return number between 1 and 10. And again, this will give me a floating point number between 1 and 10. Now if I want integers or random integers for, let's say, a sample, I can generate a random sample using the sample function. So I want a random sample from numbers 1 to 10, and I want one result or one value returned. So here it gives me 3. And each time I run it, it will give me a different result. Now I can select more. Let's say I want a sample from 1 to 10, and I want 10 results. You'll notice here, by default, once it selects a number from a sample, it doesn't select it again. So the numbers 1 to 10 are here in a random shuffled way. We don't need to do it this way. If we want to replace or have a number come up more than once, there's also a replace argument, which we can set to t or true. And this will allow us to select numbers multiple times. You'll see in this set, 10 has been selected twice. And if I run it again, we get a different set of results. So here you can see 7 has been selected 3 times, 2 3 times, so there's 2, 2, and 2, and we get 1 and 1. So that's because of this replace equals true. By default, it's set to false, or you can just put F. And this will give us the shuffled set that doesn't repeat any numbers. A good analogy to this is, let's say we wanted a deck of cards, say from 1 to 52, and with no replacement. Now if we put this in a variable, say a single deck of cards, and we want the first 5 cards. So we could have these numbers represent certain numbers or faces. Another thing we'd like to do is have a normal distribution, but chosen at random. The way of doing this is using the rnorm function. So we could do rnorm, we want 100 points chosen, and we want a mean of 0 and a standard deviation of, let's say, 2. So if we run this rnorm, it might be kind of hard to see here, but our mean is 0, so we have some negative, some positive, and it's chosen at random around this normal distribution. So if we plot a random normal distribution, rnorm, let's give it a large result, let's say 5,000, and we want the same thing, mean 0, and standard deviation of 2. You'll see here the plot. So if we look at the 0 here, so this is the mean, and we have a standard deviation of 2. So that generally fits what we'd expect for a normal distribution around the mean of 0, with the standard deviation of 2. Now the norm function has some other variations, so if we do a help on rnorm, so we get a normal distribution, we could use the dnorm variation, which gives us a density function, pnorm gives us the distribution function, and qnorm gives us the quantile function. There's also the rbinom for a random binomial distribution. So let's say we want 10 numbers chosen, either 0 or 1, and the probability of a 1 is 50%. So we can think of this as a coin toss. So we want to toss a coin 10 times, and it's a fair coin, so it's a 50-50 chance of either heads, let's say heads is 1, and tails 0. So if we look here, you see in this case we do get 5 1s and 5 0s. You can do it even larger. Let's say we want 100 coin tosses. Again, so there should be roughly the same number of zeros and ones. Now we can modify this. Let's say we want, let's go back to 10 so it's easier to see. Say we want a bent coin or an unfair coin. Let's say there's only a 20% chance of heads with this coin, and which makes 80% tails. So if we do a large one, we should see a lot of zeros in this result. So there's, just by visual inspection, we see there are quite a number of zeros in this result. And we could go the other way. Let's say our unfair coin has an 80% chance of heads. We should get a lot more ones. So that'll be the binomial or a random binomial. And if we do the help function, so help on random binomial, you'll see the binom function, the binomial distribution, also has the density, the distribution function, and the quantile function variations of the binom. And that'll conclude this introduction to random numbers, random samples, and random variates using norm and binom functions in R.